Hello, my name is Logan French, and I will be presenting on groundwater-lake water interaction using seepage velocity point measurements at an oil spill site. Several decades ago, an underground oil pipeline ruptured, spilling crude oil into the subsurface. Though the site has been a major USGS site for studying oil spills, the lake nearby has not yet been looked at comprehensively. This project uses streambed point velocity probes, or SPVPs, along with slug tests to characterize groundwater surface water flow at unnamed lake. The SPVP is a relatively new technology used to directly measure real-time seepage velocity using mini tracer tests. Tracers released at an injection port, shown here, and carried across detectors, which then send a signal to a data logger. Flow direction is determined by looking at these signals. Here we see a sketch of the probe color-coded to match the signal colors on the right. So this would be a hit just on the upwards detector and baseline at the other two. So that means tracer is injected and it's just carried past the upwards detector. As a complement to the SPVP data, we also used a more traditional Darcy approach using head gradients and hydraulic conductivity. Water levels in wells in the surrounding aquifer were combined with the K values generated by slug testing to create the flow vectors shown in the image on the right. These calculations produce flow velocities in the aquifer of about 0.04 meters per day. The K values for sand and muck, sand in yellow and muck in brown, are shown on a log scale so that they could all be seen on one graph. So that means that the differences shown here are actually more extreme than they look on the graph. Using conventional flow-through lake understanding and the Darcy calculations discussed, a conventional conceptual model was created, shown here. In this model, the color-coded arrows represent relative contaminant level in the water. Groundwater is expected to come in on the upgradient side, especially near the shoreline, and mix with the bulk lake volume, and then exit down gradient. So the original idea and hope was that this high level of interaction would generate relatively cleaner water by natural attenuation and dilution in the lake. SPVP and slug test results are shown both in map view and cross-section view. We have the northern transect, so that corresponds to this, and then the southern transect, so that's the lower line down here. These data have resulted in several conclusions. So we have horizontal flow is generally to the east, as we can see in these two diagrams, and that corresponds well with the Darcy calculations as well. Seepage velocities at the interface are also orders of magnitude higher than either the aquifer calculations or measurements made in the muck. So that was a very unexpected result for them to be that much significantly higher. In the aquifer, we have about 0.04 meters per day. The muck is about 0.2 meters per day, and the seepage velocities around the interface are about 5 to 20 meters per day, so significantly higher. So that leads us to a few conclusions. We have, based on our data and observations during the 4 field seasons, we have water pressurized beneath the muck, groundwater skirting the base of the lake, around the lake bed between the muck and the lake bed at elevated speeds, and discharge to the lake at levels less than expected. Our 4 field seasons of work have led to this updated conceptual model where the muck acts as an aquitard and redirects water in a pressurized zone of very high seepage velocities. For our site, this means lower mixing rates, faster bypass of the lake, and ultimately little opportunity for natural attenuation of pollutants, which was the hope in the original model. This preliminary conceptual model diagram represents a model of groundwater surface water interaction that has not been presented before. And this may be significant in the other lakes of the region, which there's a lot of very small lakes with thick layers of muck in them. And so our future work is focused on creating a literature and data review of surrounding lakes to compare and see how well our new model matches with those. Thank you.